So, Module 3 is our last module of Chapter 3 on genes, environment, and development. And so we've been talking about chromosomal abnormalities, sex chromosomal abnormalities, and got into a little bit about intelligence, inheritance. We're going to wrap up the chapter talking about psychological disorders and their level of heritability. And then, more importantly, the concepts of gene-environment interactions and the concept of epigenesis or epigenesis. So first off, we're going to talk about temperament and personality correlations. We talked a little bit at the end of Module 2 about temperament. These are kind of the inherited tendencies that you might see in newborns and young infants regarding their sociability, their irritability, and such. And you can see there with identical twins, it's about a 0.5 to 0.6 correlation, which basically means that is the genes influence, and then the environment is the rest. And you see with fraternal twins, those correlations are almost zero. So what that basically says is that our temperaments are somewhat of a genetic influence, but that environment does play a pretty significant role in our overall personality. As far as psychological disorders, I teach abnormal psychology, and the heritability ranges depending on the type of disorder that you might have. So we're not going to be going into great depth. Just know that genetically you can have some inheritance of disorders, or at least a tendency towards developing certain disorders based on your genes. And so schizophrenia is one that is pretty highly genetically related. And you can see here the identical twins. If you have one twin that has it, there's a 48% chance the other identical twin will have it. Now, fraternal twins that share a lot of environmental influence, but not necessarily the same genes, are only at a 17% risk. So quite a bit of a influence genetically. And you also know if you have a parent that's affected, you also are going to have a greater risk. Now, before we get into much further, the thing to talk about with psychological disorders is something called a diathesis stress kind of concept. What we mean by diathesis stress model, and this is going to come up again later in the semester, but the idea is that we have genetic weaknesses, and that those genetic weaknesses by themselves does not mean you develop the disorder, but rather when you increase your environmental stress, you have an odds of that weakness kind of going full blown. So the analogy I've always used is if you think about a chain link and you have a sledgehammer and you begin hitting each of those links with the sledgehammer, most of them are going to hold and stay. But if you've got a bad weld on one of those chains, you hit it with the sledgehammer, it's going to break open. That disorder is going to become present. And so you can see here's the probability of a major depressive episode and how many stressful life events it takes. And as you can see there with one, the genetic potential, whether protective or not, doesn't really matter a whole lot. But as you get more and more of stressful life events, the odds of developing depression go up steeply for those that have high-risk genes, and only go up very moderately with protective genes. But it also should be noted that even if you have protective genes, it doesn't make you invulnerable. It just makes it takes a lot more for a particular disorder to develop. So that's kind of the highlight of psychological disorders in regards to genetics. The gene-environment interaction, this is something I want to spend a little bit of time with because I think it's real important for you all to know and kind of appreciate. So the whole concept of a gene-environment correlation is the way that your genes and your environment are systematically interrelated. And they're interrelated according to either a passive, evocative, or active genotype environment correlation. So both genes and environment are at work over the entire lifespan, even though the relative contribution of genes and environment change from going from infancy to adolescence and then even into adulthood. So the first one we're going to talk about here is a passive genotype environment interaction. And passive is The idea that the environment that you initially grow up in is going to be suitable to your genotype because you inherited your parents' genes and your parents are living in places that tend to fit their genotype. So the idea is if you have parents that are both kind of mild, retiring, don't like a lot of excitement, they decide to move to a more rural area where things are quieter, a little bit slower. And the odds are that you're going to really thrive in that setting too, because you inherited your parents' genes, which means you probably have a higher tendency for that type of environment gene fit. But you had no selection in that. So it's a very passive influence. And this passive influence is obviously going to have its most impact in early childhood and up through until adolescence, because you don't really have a whole lot of pick there. The second gene environment correlation is going to be the evocative one. And what this says is the genetic makeup, it may affect the reaction other people's have to a child, and hence the kind of social influence or environment that the child experiences. So, two examples. Let's say you just happen to be blessed and everybody finds you drop dead, gorgeous, attractive, handsome. And so you go through life with people treating you differently, giving you favors, opening doors for you, acting out of kindness, but also trying to help you out wherever they can. You're evoking that with your beauty, your good looks. You're evoking a nice response from those in your environment. And therefore, you have an advantage and will probably be more likely to succeed. If you just happen to hit the ugly branch all the way down and you are just one ugly kid, you are going to have to overcome that, because people do not warm up to ugly people like they do to pretty people. And it's hard to say that, but it's very true. And it starts very early on in life. Young children will react differently to beautiful people versus those who are more ugly. And so they are evoking a response in a very different manner, but it's still an evocative gene environment correlation. Now, that's going to have an influence pretty much throughout a person's life fairly evenly, of course, unless you have plastic surgery or something else like that. And then the last is your active genotype environment correlation. And active is, as you get older, you're going to seek out environments that meet your genes. So let's say you still got you're a child of those parents I described earlier, kind of shy, retiring, like slower pace of life. So they go ahead and move to a rural area, but you somehow got this combination between the two of them that you're an adrenaline junkie and you can't wait to get out of that rural area. And the moment you can go skiing or surfing or whatever it might be, you're on it. You're going to go ahead and move to an environment that allows you to do that. But you're actively sensing or seeking that out. That's why we call it an active gene environment. And of course, you have more choice in what environment you want to be in the older you get. Okay, so passive tends to be younger ages, evocative tends to be pretty consistent throughout the lifespan, and active tends to increase as you get older. Okay. The last thing we're going to talk about in this chapter is the concept of epigenesis or epigenetics. And this is how your experiences of previous generations affect our current generation. And it is a fascinating topic that I will admit I do not know a ton about. But they had a special on PBS that called Ghost in the Genes. And they did this study out of Iceland. And basically, Iceland was perfect because you didn't have a lot of people moving in and out of it. And they did really wonderful work with genealogies. And what you found is that the behavior of the grandmother could influence the second generation on. So when grandmother had the mother, that early environmental experience wouldn't necessarily pass on. But then the generation after that is where you saw the effects. With this epigenetic effect, where they found it most prevalent was where they had documented famines when the grandmother had been in the womb herself, and her eggs had been negatively impacted by the fact that there was starvation and a real famine going on. She was born, grew up, had a child, no issues. And then that child became a mother herself, then that child, that second generation, would have a tendency towards obesity. And that was because food was in such short supply. The genes that got passed on to future generations actually didn't change, but when they were turned on and off, did. So it's very hard to change genes, but it isn't as hard to change how long they stay on or off. If you think about it, like our height, our growth in height, it depends on how long, like our pituitary gland keeps putting out these growth hormones. And usually for all of us, it's going to end somewhere in the say 13, 14 years old, all the way up for men, almost up to 20. But it does stop. And so we have a certain height. That's kind of as far as we can go. So if you get these influences, for example, the ability to retain fat, those genes don't turn off as quickly in this kind of epigenetic influence. So I don't know if I did a real good job with that. Just know I wanted to make you aware that it's out there, and that certainly goes with this chapter. I'm not doing it justice. So if you are curious, do go ahead and do a Google search and kind of look a little more in depth. But wanted to leave you with that. So that is chapter 3. And we're going to go ahead and continue our kind of blitz through our next few chapters on chapter 4. So tune in for that, and I will see you then.